Welcome back, ladies and gentlemen. We are going to start by looking at our shorthand notation practice that we should have done last class period or through the last video. So let's go over this really quickly. So for selenium, for shorthand, the nearest noble gas to selenium would be argon. Argon, we put in brackets. That means the electron configuration for argon. And then we go from argon to potassium, and we get 4s2, 3d10, 4p4. Potassium, well, argon is its closest neighbor as well, without going over. And then finally, 4s1 gets us to potassium. And then calcium, well, that's right next to potassium, so argon 4s2. Now finally here we have iodine. Iodine is not in the same row as selenium, potassium, or calcium. So we have a different noble gas. We're going to reference krypton. So this means the electron configuration for krypton, plus we have 5s2, 4d10, 5p5. And then bismuth, again, even a different noble gas. This time xenon is being referenced, and we have 6s2. Then we have to go drop down and get 4f14, and then 5d10 comes in, and then finally 6p3. Okay, so there are the answers to the last video's practice. Okay, so today we're going to be talking about electrons, especially valence electron configurations and how we figure that out. We already know how to do electron configurations. Now we just have to figure out how to do these things called valence electron configurations. So here we go. So valence electron configurations, what are they? Okay, the word valence means outermost or highest energy level. So we're looking for the energy level that has the highest or the outermost number. So electron configuration for boron is 1s2, 2s2, 2p1. So the highest electron configuration here will be the 2, because 1 is lower than 2. 2 is the highest here. We have 1 and 2 2's. So when we choose the valence electron configuration, we have to look at the highest energy level. The highest energy level would be 2. So then what would the VEC be? The VEC would be everything that has a 2. So that's a 2s2, 2p1. And that would be the VEC for boron. So if we go to the next one is the electron configuration for bromine. Here's the electron configuration for bromine. So we have choices. We have 4, 3, and 4. What is the highest? The highest level would be 4. So anything with a 4 is going to get mentioned in the VEC. So this has a 4 and this has a 4. So we're going to say 4s2, 4p5. All right, next example. Next example is lead. Here's lead's electron configuration. We have xenon. Ooh, there's a problem there. I've missed something. Miss Stover made a mistake. There should be something right there. There should be a 4f14 right there. So we have 4 to choose from, or 3 to choose from: 6, 4, 5, and 6. So what's the highest? The highest energy level would be 6. So everything with a 6. So that's 6s2, 6p2. So we would write 6s2, 6p2. Okay, last example here. Magnesium. Here's the electron configuration for magnesium, Ne3s2. So what's the highest energy level? Well, all we can see is a 3s2, meaning everything below that is lower. So 3 would be the highest energy level. So what would the VEC be? It would be 3s2, everything that has a 3 in it. So we know something about these. We just practiced them. Now I want you to write or underline or write the VECs for each of these examples.